Let's start with the objectives of this tutorial. Constructive interference versus destructive interference is a more superficial comparison to understand the wave interaction. Now we will see what factors aid in determining the difference between constructive interference and destructive interference. The factors are: constructive interference versus destructive interference, considering amplitude. Constructive interference versus destructive interference, considering waves. Constructive interference versus destructive interference, considering frequency. Constructive interference versus destructive interference, considering amplitude. The constructive interference is termed as such because the two waves meeting one another will have their respective amplitudes. When they encounter each other, the amplitudes of the two waves will merge and result in one single wave of equal amplitude. The wave appearing in the same medium being a resultant has an amplitude that is way much higher. So, in this case, the medium in which the constructive interference occurs will have an upward displacement. The resultant upward displacement of the resultant wave is larger than the individual displacement of the two waves interfering. The constructive interference occurs along with medium and in the same direction as the originating waves. Let us take an example where the constructive interference is influenced by the amplitude. Consider two pulse waves traveling in the same medium, also in the same direction. They will have particular amplitude individually. In destructive interference, the waves having a 180 phase will cancel out each other if the two are positive and negative. The individual amplitude value is larger than the final wave of amplitude that is way much smaller. The waves interfering have nodes which are called the ends of the wave. The constructive and destructive have the nodes that match at the exact location, which is the resultant wave of the interference process. Constructive interference versus destructive interference, considering wave S. Wave patterns that appear in general are due to the consequence of interference of the two waves colliding with each other. When the waves interfere, the resultant wave pattern appears in the same direction, since the amplitude has the more significant measure. Here the crest and crest meet each other. But in destructive interference, the wave pattern appears opposite to each other. The resultant wave pattern in a destructive interference will always have an opposite where the crest of one wave will meet the rough of the other wave. Also, the amplitude of the displaced wave will be smaller than the individual waves that interfere with each other. Let us see how wave patterns are formed when the interference process takes place in a pool. When we stand inside the pool with both hands stretched and move back and forth, there will arise a wave pattern. The wave pattern is simply the wavefronts of the primary waves when they undergo interference. When both hands have been stroked back and forth, it will form a wave pattern. The troughs in the wave pattern will cancel out each other. The canceling of the troughs of the wave is termed destructive interference. The area of the wave pattern which keeps on increasing is a sign of the addition of the waves. This is termed constructive interference. These wave patterns are essential not only in water sound, but mainly in light too. In light, when the light waves hit a surface that has a gap in it, the diffraction pattern is obtained. When one single beam enters the hole, it will come out as a whole set of waves. Constructive interference versus destructive interference, considering frequency. Generally, constructive interference occurs when the crest and crest of two interfering waves meet each other. Due to this, the amplitudes also will add up and form a wave pattern of the same individual waves. When the frequency of the waves appear to be the same, then the resultant wave will be the same and appear in the same medium. When we consider the sound waves, the sound will be heard more in constructive interference. When a number of cycles happen at a particular point given is certainly termed to be the frequency, and it also related to amplitude of the resultant. Hence, when constructive interference versus destructive interference occurs, it will have so many factors that will influence the secondary wave pattern in general. Frequently asked questions. What is the interference of light? When the two light waves interfere with each other is termed light interference. The disturbance of light due to one deformed wave will lead to the interaction of the two waves. Interference of light occurs if the light waves have the same amplitude, frequency, and also should be coherent. What is the destructive interference example? Noise-canceling headphones are one of the prominent examples of destructive interference. When the headphone has a microphone attachment, it will gradually pick up the frequency of the waves of the incoming. So the amplitude will be less when the resultant wave is displaced in opposite to one another. What is a good interference example? One good example of sound wave interference is musical instruments. For instance, let us consider guitar. When two guitars are tuned in phase, they will sound the same when played. But if the tuning is different, we get to hear different notes while hearing. When speakers play a sound, if they play with the same amplitude, then we call it constructive interference. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.